So today we are going to talk about multiplying binomials with radicals. So we've already worked on a problem like this, where we just use the distributive property for 1. And so we're going to distribute that radical 3 and we get radical 6 plus 4 radical 3. So those we can kind of handle. What about something with two binomials multiplied by each other? So remember, binomials have two terms. So what if we have 4 plus radical 6 and we want to square that? Well, that's going to be 4 plus radical 6 times 4 plus radical 6. And pause for a moment. Do you remember the pattern for a plus b squared? A plus b squared. Do you remember what that looks like? It's a squared plus 2ab plus b squared. And remember, we learned this when we were factoring because it made it easy to factor if we could recognize something was in this format. So if we remember that, we can actually use the pattern to go ahead and figure out what 4 plus radical 6 squared is going to look like. It's going to be 4 squared plus 2 times 4 radical 6 plus radical 6 squared, which is going to give us 16 plus 8 radical 6 plus 6, so 22 plus 8 radical 6. Now if you don't recall the pattern, we can do it just using FOIL. So first would be 16, that's 4 times 4, and then outer is going to be plus 4 radical 6, inner is going to be plus 4 radical 6, and then last is going to be plus radical 6 squared. So that's going to give us 16 plus 8 radical 6 plus 6, which is 22, plus 8 radical 6. So let's look at another problem. Alright, what if I have 3 radical 3 minus the square root of 10, and I want to square all that? Again, we have a pattern, and it's a minus b squared equals a squared minus 2ab plus b squared. So I can either FOIL this, or I can just use my pattern. So I'm going to hope that you're comfortable with foiling, and I'm just going to use our pattern. So we're going to have 3 radical 3 squared minus 2 times 3 radical 10 plus radical 10 squared. So 3 squared is 9, square root of 3 squared is 3, so I'm going to get 9 times 3, which is 27, minus, well here I'm going to have the square root of 3 times the square root of 10, which is going to be the square root of 30, and 2 times 3, which is going to be 6, so 6 radical 30, and then the square root of 10 squared is just 10. So I have 37 minus 6 radical 30. And does 30 contain any perfect squares or anything like that? It does not. So that's simplified. So 36 minus 6 radical 30. Let's look at another one. How about this? 5 plus radical 7 times 5 minus radical 7. Well, again, we have a pattern. Do you remember what that was? It's just the difference of two squares. So you'd have a squared minus b squared. So for this problem, I'm going to end up with 5 squared minus square root of 7 squared, which is 25 minus 7, which is 18. Let's look at this again in our next video.